Hey guys, today we are going to solve the easy problem. Remove duplicate from sorted array 2. It says, given an integer array nums sorted in non-decreased order, remove some duplicates in place such that each unique element appears most twice. The relative order of the elements should be kept the same. Since it is impossible to change the length of the array in some languages, you must instead have the result be placed in the first part of the array nums. More formally, if there are k elements after removing the duplicates, then the first k elements of nums should hold the final result. It doesn't matter what you leave beyond the first k element. Return k after placing the final result in the first k slot of nums. Do not allocate extra space for another array. You must do this by modifying the input array in place with O1 extra memory. And you are given an example, this list of number that holds 1, 1, 1, 2, 2, 3. And you are going to return the list with only 2 ones, 2 twos, and 1 3. And the 5 that represent the amount of items you have in this list. So how can you solve this problem? First, remember that you must do this. Remember that this problem has a few conditions. First, this problem should be solved in place. It means that you can create a list of numbers, a new list of numbers, where you put the items there. Now you move in the very own list, remove the elements that appear more than twice, and also you must return the length. You must return the number of items you have in this new list. How can you solve this problem? Actually, it's pretty simple. To solve it, we are going to suppose we are going to create a new list, but you are not going to create a new list. We are going to solve it in place. First, you are going to create a pointer. It's going to point to the first element of our list, and also this pointer will be the last element that we know it appears at most twice. So this pointer will point always to our new list, or to our new list without elements that appear twice. And you're going to create another pointer, or reverse pointer. This pointer will traverse our entire list of numbers. Then you already have two pointers. A that points to our list that we know that elements appear at most twice, and also our right pointer that will traverse all our elements. So, how are you going to solve this problem? You are going to take our right pointer and compare whatever is to the left of our left pointer. So if whatever is to the left of left pointer is different than our right pointer, you are going to move our left pointer and put there whatever it's pointing or right pointer. So let's read it. Check if the number at position left index -1 is different than our current right pointer. So let's check it out. So it's our left element to our left pointer different than whatever it's pointing or right pointer. Yes, it's different. So because it's different, we are going to move our left pointer up and put there whatever it's pointing our right pointer. So we are just going to put 0. And here, remember that it's in place and you must put 0. And now let's move our right pointer. So if a right pointer different than whatever is to the left or left pointer, yes, it's different because here you're pointing 1 and here you're pointing 0. So you're going to move our left pointer to its right and put there whatever our right pointer is pointing. So here you're going to put 1 and move our right pointer, remember. So once again, is whatever we are pointing to our right pointer different that the position to the left of our current left pointer? Yes, because here we are pointing 0 and here we are pointing 1. So you're going to move our right pointer and put there whatever is pointing our right pointer. So you're pointing 1 here, so put 1 here. And remember the in place, so here you must write 1. So let's do it once again. It's a right pointer different than whatever it's pointing or left pointer to its left? No, because they are pretty much the same. Here you have 1 and here you have also 1. So let's move our right pointer. So if our right pointer different than whatever it's pointing or left pointer to its left, no, they are pretty much the same. So move our right pointer. So you have 2, and the thing on the left of our left pointer it's 1. So remember, move our left pointer to its right and put whatever it's pointing or right pointer. So 2, and remember there 2. By the way, don't forget this isn't a new array, this is just for my explanation. So once again, you have the number 3. It's 3 different the number to our left or of our left pointer. Yes, they are different. So move our left pointer to its right, put whatever it's pointing or right pointer, and see how you already have this list. And let's do it once again. If different or right pointer to whatever number is to the left of our left pointer, yeah, they are different. So you move our left pointer and put there whatever is pointing our right pointer. As they are different, you're going to move the right pointer here, and you already have traversed our list. And this list that begins as these numbers and thus being this. and you can see it's correct. And remember that you must return the amount of elements our new leaf have. So we have 1, 2, 3, 4, 5, 6, 7 numbers. And our left pointer is the position 0, 1, 2, 3, 4, 5, 6. So you are going to return our left pointer plus 1. Okay, perfect. So let's do it on code. Let left pointer equals 0 and let right pointer equals 1. We are going to traverse the entire list of numbers as long, and we are going to traverse our entire list of numbers. So what do we check? We check if the number at position left index -1 is different than our current right pointer. So if num at position left pointer -1 is different than num at position right pointer. We remember that we move our left pointer to its right, left pointer to its right, and put there whatever is pointing our right pointer. And finally, you are going to return a left pointer plus 1. And by the way, if you have a list of numbers that have only two elements, you must return the amount of elements of that list. So if the length is lower or equal than 2, you're going to return the length. So let's take this code. This should be working, and let's submit it. Okay, perfect. And as you can see, it's based 53% of all the cases. And by the way, this can really change because LeetCode is kind of strange sometimes. Sometimes can be 53, sometimes 96. LeetCode sometimes is really strange. So this problem was literally the same as the 26 problem, remove duplicate from sorted array. It's the same. The unique difference is that you don't subtract 1. Okay, perfect. Literally it's the same problem. It's literally the same. Just here you're going to check one number to the right, to the left. Well, and that's all for today. See you tomorrow for another video. Bye bye.